Somewhere right now, a piece of light is traveling toward Earth. It left its source over 100 light years ago, and when it finally arrives in a few years, it will fall into a telescope mirror, and it will tell us something we have never been able to say for certain before: that we might not be alone. Not a blurry photo, not a grainy radio blip, not a conspiracy theory whispered on the internet at 2 a.m. This is different. This is a signature, a chemical fingerprint found in the atmosphere of a planet 124 light years away that on Earth is made by only one thing: life. Scientists have spent decades chasing shadows, false alarms, signals that turned out to be satellites or swamp gas or wishful thinking. This time, something is different. This time, some of the most cautious minds in science are choosing their words very, very carefully because they know what it means if they're right. So let's start where they started, with a number, a molecule, and a question nobody expected to be asking this soon. Are we finally looking at proof? Let's rewind for a second, because to understand why this discovery matters, you have to understand how strange it is that we ever got here at all. For most of human history, the stars were just light, points in the dark. We didn't know they were suns. We didn't know they had planets. We certainly didn't know that some of those planets might have oceans or skies or something moving quietly beneath the clouds. Then in the 1990s, everything changed. Astronomers found the first planet orbiting a star other than our own, not directly seen, just a tiny wobble, a flicker in starlight, a shadow passing across a distant sun. But it was enough. It was proof that our solar system wasn't the only one, that planets weren't rare, they were everywhere. Since then, we've found thousands of them. Rocky ones, gas giants, worlds so close to their stars that a year lasts a single day, worlds so far out they barely feel their sun's warmth at all. And somewhere in that flood of new worlds, scientists started at asking a quieter, more dangerous question. Not just, is there a planet there? But, could something be living on it? That question led them to a very specific kind of place. Not too hot, not too cold. Close enough to a star for liquid water to exist, but not so close that it boils away. Scientists call it, almost poetically, the habitable zone. Some people call it the Goldilocks zone. Not too much, not too little, just right. And in 2015, in that exact kind of place, orbiting a small, dim, red star 124 light years from here, they found a planet called K218b. At first, it didn't look like much. Just a number, a dot of data in a spreadsheet, almost 9 times the mass of Earth. Bigger than us, but small enough to maybe, possibly, be rocky. Or at least have a surface of some kind, a place where water could pool instead of just floating as gas. For years, that's all it was. A candidate. One of thousands. Nobody was talking about it at dinner tables. Nobody was writing headlines. Then came the telescope that changed everything. In December 2021, humanity launched a piece of engineering so precise, so unbelievably delicate, that a single misaligned mirror segment could have ended the entire mission before it began. The James Webb Space Telescope didn't just look at stars. It looked through them. Specifically through the thin, faint atmospheres of planets passing in front of their stars, reading the light like a chemist reads a flame test, picking apart which wavelengths got absorbed and by what. Because here's the thing about atmospheres. They leave fingerprints. Every gas absorbs light a little differently. Methane leaves one signature. Carbon dioxide leaves another. Water vapor, another still. If you have a telescope precise enough, you can hold a planet's atmosphere up to the light 124 light years away and ask it, very simply, what are you made of? So in 2023, Webb turned toward K218b, and what it found made a small group of scientists go very quiet. Methane, carbon dioxide, signs, tentative but real, of water vapor. It matched a theory some scientists had proposed years earlier, that certain sub-Neptune planets might not be rocky at all, but something stranger, A world with a thick hydrogen atmosphere sitting over a global ocean, warm and deep, maybe hundreds of kilometers down. They gave this hypothetical kind of world a name before they even knew if it was real. They called it a Hycean planet. Hydrogen. Ocean. A word built for a place we'd never confirmed existed, and K218b fit the profile disturbingly well. But that alone wasn't the headline. Methane and carbon dioxide are common. Boring, almost, on a cosmic scale. What made scientists lean in closer, what made some of them stop sleeping properly, was something else buried in that same light. A molecule that, on Earth, is produced almost exclusively by one thing. Not volcanoes, not lightning, not chemistry alone. Life, specifically marine life. Phytoplankton, algae, the microscopic engines that quietly run entire ocean ecosystems here on Earth. They breathe out a gas called dimethyl sulfide, DMS for short. It's part of why the ocean smells like the ocean. And outside of biology, we don't have a good explanation for how it forms in any meaningful quantity. When the data came back suggesting a possible trace of DMS in K218b's atmosphere, the scientists who found it didn't celebrate. They didn't call a press conference and declare victory. They did something much more telling. They got cautious. Caution in science is not the absence of excitement. It's what excitement looks like when the stakes are this high. Because think about what's actually being claimed here. Not a planet. We'd already found thousands of those. Not even a habitable zone, or water, or the right temperature. Those things make a planet interesting. What DMs suggested, if it was really there, if the signal held up, was something else entirely. It suggested biology, an active breathing process currently happening on a world we've never touched, around a star most people have never heard of. That's not a discovery you announce lightly. That's a discovery you try to kill first. So that's exactly what the team did. Led by astronomer Niku Madhusudan at the University of Cambridge, the scientists behind the K218b findings did what good scientists are supposed to do when they see something that looks too important to be true. They turned on themselves. They asked, what else could explain this? What non-biological process, what strange chemistry unique to alien atmospheres, could fake this signal and fool us? They ran the numbers again. They checked instrument calibration. They asked whether volcanic activity or some exotic photochemistry in an atmosphere unlike anything on Earth could produce dimethyl sulfide without any life involved at all. And here's the uncomfortable truth about this whole story. The part that never makes it into the more sensational headlines. They couldn't fully rule it out. Not because the science was bad, because the tools we have, even a telescope as extraordinary as Webb, are working at the very edge of what's physically possible. K218b is 124 light-years away. That's roughly 730 trillion miles. The light we're analyzing didn't just travel a long distance. It traveled through a planet's atmosphere first, getting bent and filtered and faded before it ever reached a mirror built by human hands. Reading a molecule's fingerprint in that light is a little like trying to identify a single word whispered across a stadium, through a wall, during a thunderstorm. The detection of DMS, when it was first announced, sat at a confidence level scientists call 3 sigma. In plain language, there was roughly a 1 in 370 chance the signal was just statistical noise. Sounds convincing, sounds like enough. But in physics, in the fields where the biggest claims get made and unmade, 3 sigma isn't proof. It's a maybe worth investigating. Particle physicists waited for 5 sigma, a 1 in 3.5 million chance of error, before they'd even whisper the words Higgs boson. Astrobiology, for now, hasn't set its own bar quite that high. But everyone in the field knows what real proof requires. And this wasn't quite there yet. So the team went back, gathered more data, reanalyzed everything with sharper instruments and more observation time. And in early 2024, a second round of results came in, and DMS was still showing up in the data. Not stronger, not definitively confirmed, but not gone either. That's when other scientists, the ones who hadn't found the signal themselves, the ones with nothing personally invested in it being real, started weighing in. And this is where the story gets more interesting, not less, because some of them pushed back hard. A team led by researchers studying planetary chemistry pointed out something uncomfortable. DMs had never actually been confirmed to exist on any exoplanet before. Not with certainty. What if the signal being picked up wasn't DMs at all, but something that just resembled it in the data? A kind of spectral illusion. Other scientists ran laboratory experiments recreating hydrogen-rich atmospheres like K218b's, trying to see if entirely lifeless chemical reactions could cook up DMs on their own. No biology required. Some early lab work suggested it might be possible, under the right pressures and temperatures, for sulfur compounds to rearrange into something that mimics a biosignature, without a single living cell anywhere near it. In other words, this became a real scientific fight. Not the manufactured kind, not headlines competing for clicks. The genuine kind, where careful people who've spent their whole careers studying atmospheres disagree publicly about what the data actually shows. And maybe that's the part that should make you lean in closer, not pull away. Because if this were fake, if this were hype dressed up as science, nobody would be arguing this hard about the details. You don't need 3 sigma confidence levels to sell a conspiracy. You need them when you're trying not to fool yourself. Here's what makes K218b different from every alien signal that came before it and fizzled into nothing. We've been fooled before. Badly. In 1967, a young astronomer named Jocelyn Bell Burnell picked up a signal so regular, so precise, so unnaturally rhythmic that she and her team nicknamed it LGM-1. Little Green Men. For a few electric weeks, some of the smartest people in astronomy quietly wondered if they'd just found evidence of an alien civilization, broadcasting into the dark with mechanical perfection. It turned out to be something almost as strange. A pulsar, a collapsed star spinning hundreds of times a second, flashing radio waves like a cosmic lighthouse. Not aliens, but a real discovery, one that reshaped physics. In 1996, a meteorite from Mars, found frozen in Antarctic ice, seemed to contain microscopic structures that looked eerily like fossilized bacteria. NASA held a press conference. The President of the United States spoke about it on television. And then, slowly, painstakingly, other scientists showed that every one of those structures could form without biology at all. Through ordinary mineral processes, no life required. And in 1977, a radio telescope in Ohio picked up a signal so strong, so unexpected, that the astronomer monitoring the data printed it out, circled it in red pen, and wrote one word in the margin. Wow. The wow signal has never been explained. It is also never repeated. Not once in almost 50 years of listening. Notice the pattern in all 3 of these. Each one made headlines. Each one, for a moment, felt like the discovery that would change everything about how we saw our place in the universe. And each one, eventually, either got explained away by something ordinary, or got quietly filed under unresolved and left there, unproven, unrepeatable, unreachable. K218b is different for one very specific, very unglamorous reason. It's not going anywhere. A radio signal can be one moment and gone the next. A whisper caught once and never heard again. A meteorite is a single fixed sample, studied once and argued about forever. But K218b is a planet. It orbits its star every 33 days, over and over and over again. Every time it crosses in front of that star from our point of view, its atmosphere is right there again, ready to be read. Scientists aren't chasing a ghost. They're watching a door that keeps opening on a fixed schedule, and every time it opens, they get to look through it again. That's the quiet power underneath this story. This isn't a claim you either believe or don't. It's a claim you can keep checking, keep testing, keep trying to break. And that's precisely what's happening right now, in real time as you're hearing this. More observation time on the James Webb Space Telescope has already been allocated to K218b. Competing teams, some hoping to confirm the signal, some actively hoping to disprove it, which is exactly how good science is supposed to work, are analyzing the same wavelengths with different methods, different assumptions, different statistical models. Some of that fresh data is expected within the next couple of years. Not decades, years. Which means something almost unprecedented in the history of this question. For the first time, are we alone isn't a philosophical debate happening at a dinner table, or a line in a science fiction movie, or a hypothetical buried in a physics textbook. It's an active research question with a timeline, with named scientists racing to answer it, with a specific planet, a specific molecule, and a specific number attached to how confident we should be. Think about what that actually means for a second. For all of human history, every civilization, every religion, every scientist who ever looked up and wondered, that question sat in the same category as what happens after we die? Or why does anything exist at all? Unanswerable. Not because we lacked curiosity, because we lacked a method. There was no experiment you could run, no data you could gather. Just wonder, stretching endlessly into the dark, with nothing to hold on to. That changed quietly sometime in the last few years, and most people haven't fully absorbed it yet. We are, right now, alive during the first period in human history when is there life beyond Earth has become a question with an actual research pipeline behind it. A telescope, a team, a schedule of observations, a statistical threshold we're trying to cross. It might turn out to be nothing. DMs might get explained away, the way the Martian meteorite was, the way so many almost discoveries have been before. That's a real possibility. And any honest scientist working on this will tell you so without hesitation. But it might not. And either way, something has already shifted. The question itself has changed shape. It used to live in the realm of philosophy and imagination. Now it lives, at least partly, in a spreadsheet, sitting on a server, waiting a as. Let's sit with something for a second, because it's easy to rush past it. K218b is 124 light-years away. That number sounds abstract until you actually try to feel it. Light moves faster than anything in the universe. Nothing outruns it. And even at that speed, 186,000 miles every single second, it still takes light 124 years to cross the distance between that planet and us. Which means the light web is analyzing right now. The light carrying whatever answer is hiding in that atmosphere, left K218b around the year 1900, before either World War, before antibiotics, before anyone alive today was born. If there is something alive on that planet right now, breathing out that chemical signature into its sky, we won't know about it for another century, at least in the sense of receiving fresh light. We're always looking at the past. Every telescope is a time machine pointed backward. There is no version of this discovery where we see K218b as it is today. We can only ever see who it was over 100 years ago and try to guess who it might still be. That should feel strange. It should feel almost impossible. And yet here's the part that quietly reframes everything. We don't need to travel there to know something's there. We don't need a spacecraft or a landing or a handshake. We just need light and enough patience to read what it's carrying. That's the actual story underneath the headlines. Not spaceships, not flying saucers, not men in suits hiding files in a warehouse. Just physics, doing exactly what physics has always done, carrying information across impossible distances, faithfully, without opinion, without agenda, waiting for someone patient enough to catch it and ask the right question. And maybe that's what makes this moment different from every UFO video, every blurry photo, every conspiracy forum. This isn't a story about something hidden from us. It's a story about something we're actively, openly, carefully trying to find. In full view, published in real journals, argued about by real scientists who put their names and reputations on the line every time they publish a paper. There's something almost humbling in that. For centuries, we imagined first contact as dramatic, a ship in the sky, a signal decoded in a control room, actors gathered around a screen, someone whispering, "It's really happening." The truth, if it turns out to be true, might look almost anticlimactic by comparison. A CSV file, a spectrum graph with a small bump where a molecule shouldn't be, a group of tired scientists checking their math for the 15th time, almost afraid to believe what they're looking at, because that's usually how the biggest moments in science actually arrive. Not with fireworks, with a graph, a number that doesn't fit, a signal that shouldn't be there, and refuses to go away no matter how hard you try to explain it into nothing. Think about how strange that is, that we might learn we're not alone in the universe, not through a message, not through a voice, not through anything resembling communication at all, but through a smell, a chemical trace, the same way you'd know someone had been in a room after they'd already left it, not by seeing them, just by what they left behind in the air. If K218b really does have life in its oceans, it isn't trying to reach us. It isn't sending anything our way. It has no idea we exist, no idea we're listening, no idea that 124 light-years away, a species that only learned to fly a little over a century ago is holding its breath, staring at a spectrum graph, trying to decide if a chemical signature is trying to tell it something. That's not a message. That's just life, being life, existing quietly, indifferent to whether anyone's watching. And somehow that might be the most convincing part of this entire story. So where does this actually leave us? Not with an answer, with something more interesting, a process. A live, unfolding investigation and a set of numbers that everyone in the field is watching climb, slowly, one observation at a time. Right now, the honest scientific position is this. K218b shows a planet in the habitable zone, with an atmosphere containing methane and carbon dioxide, consistent with a Hycean world, a deep, warm ocean under a thick hydrogen sky. Layered on top of that is a tentative, contested, not yet confirmed hint of dimethyl sulfide, a molecule that, on Earth, comes almost exclusively from living organisms. The confidence level, even in the most optimistic analyses, has not yet crossed the threshold scientists require before they'll call something proven. That's it. That's the actual state of the science, without exaggeration and without dismissal. Not aliens confirmed, not nothing either. Something in between. The most tantalizing, most carefully guarded maybe in the history of the search for life beyond Earth. But here's what almost nobody says out loud enough. Maybe has never gotten this far before. Every other candidate, every other planet, every other atmosphere we've managed to sample has come back either clearly lifeless or too ambiguous to even have this conversation. K218b is the first world where actual working scientists, publishing in peer-reviewed journals, are debating not whether the planet is interesting, but whether they might be looking at an active biosignature. That sentence alone would have sounded like science fiction 15 years ago. And there's a broader shift happening underneath all of this. One that rarely makes it into the headlines about K218bi specifically. For most of the space age, the search for alien life was aimed almost entirely at Mars. A cold, dry, seemingly dead world next door, where we've sent rover after rover, mostly finding rock, dust, and tantalizing chemical traces that never quite close the case. Meanwhile, a quieter shift was happening. Scientists started to suspect that the most promising places to find life might not be rocky planets like Earth or Mars at all. They might be exactly this: sub-Neptune worlds, bigger than Earth, wrapped in hydrogen, sitting over oceans that never freeze and never fully evaporate, warmed just enough by starlight and internal heat to stay liquid for billions of years. If that's true, it changes the entire math of the search, because Hycean worlds like K218b might not be rare, exotic outliers. Early estimates suggest they could be common, more common in some models than Earth-like rocky planets in habitable zones, which means if K218b's signal turns out to be real, it's not just evidence of one lucky planet. It's evidence of a whole category of worlds we barely knew to look for a decade ago, and evidence that the universe might have far more places for life to take hold than we ever assumed when we were only searching for planets that looked like home. That reframing matters. For most of human history, when we imagined alien life, we imagined it needing what we needed: solid ground, a sun like ours, something recognizable. K218b suggests something quieter and stranger, that life, if it exists out there, might not be waiting on planets that look like Earth at all. It might be waiting in oceans buried under hydrogen skies, on worlds shaped nothing like our own, using a chemistry we're only just learning to recognize, which raises the question none of the papers can answer yet. The one sitting underneath every headline about this planet. If we do confirm it, if the next round of Webb data holds up, if the sigma climbs high enough, if independent teams stop arguing and start agreeing, what actually changes the day after? Not much, practically. K218b will still be 124 light-years away. No ship exists that could reach it in a human lifetime. No message could be sent and answered within 1,000 years, let alone one. It would remain forever, a place we can only observe and never visit, a neighbor we can see through a window but never actually meet. And yet everything would change anyway, because for the first time in the history of our species, are we alone would stop being a question and start being a fact, sitting quietly at the bottom of a peer-reviewed paper, changing how every human being who ever looks up at the night sky again understands what they're looking at. If you've made it this far with me, I want to ask you something small before we keep going. Hit subscribe, stay with us. We put out a video like this every single day. Questions like this one, the kind that sits somewhere between science and wonder, the kind most people never stop to actually chase down. If that's the kind of thing your brain likes chewing on, this is a good place to be. And while you're here, I want to know something. If it turns out K218b really does have life in its oceans, life we'll never see, never speak to, never confirm beyond a chemical trace in the dark, does that count? Does that feel like not alone to you? Or does not alone only mean something if it can look back at us? Drop that answer in the comments. I actually read them. Okay, back to the sky. Because there's one more layer to this story, and it might be the strangest one yet. Not about K218b itself, but about what happens next, regardless of how this particular planet turns out. K218b was never meant to be the finish line. It was meant to be proof of concept. Proof that this kind of detection, reading a living signature out of starlight from over 100 light-years away, is actually possible with instruments humans have already built. Before K218b, that idea lived mostly in theory papers and conference talks, a nice hypothesis nobody had actually pulled off. Now it's a real technique, tested on a real planet, producing real, arguable, scientifically serious data, which means the next generation of telescopes, some already under construction, some still on paper, aren't starting from zero. They're starting from here, from a planet 124 light-years away that taught us how to ask the question properly. Every future search for a biosignature on every future planet will trace its method back to the arguments happening right now over K218b's atmosphere. So even if this particular signal fades, even if DMS turns out to be a trick of chemistry and not biology, something will have been proven anyway. That we can do this, that the tools exist, that the only thing standing between us and an answer isn't imagination anymore. It's time and patience And one more orbit, one more transit, one more download of light that left a strange ocean world before any of us were born. So let's come back to where we started. A piece of light, older than most of the people watching this, still falling toward a mirror built by hands that will never touch the place it came from. Maybe by the time you're watching this, the answer already exists somewhere. A new paper, a confirmed signal, a number that finally crossed the line scientists have been waiting for. Or maybe it's still sitting exactly where we left it, unresolved, contested, alive in the space between maybe and yes. Either way, something has already happened that can't be undone. We asked the question properly for the first time. Not as a wish, not as a rumor whispered across a stadium, as a real, testable, falsifiable claim sitting in front of the most careful people we have, daring them to prove it wrong. And they tried. That's the part worth remembering. Not that they wanted it to be true. That they tried as hard as they could to make it not be true, and it kept refusing to disappear. 124 light-years away in an ocean none of us will ever see with our own eyes, something might be breathing right now, or it might not. Either way, that ocean doesn't know we're watching. It doesn't know a species that just learned to build telescopes is holding its breath over a spreadsheet, trying to read a whisper in the dark. Maybe that's what not alone actually means in the end. Not a handshake, not a message answered. Just knowing, quietly and for certain, that somewhere out there, something else exists, indifferent to us, unaware of us, alive anyway. If this is where the universe finally starts answering back, it won't be loud. It'll look exactly like this: a graph, a number, a silence that finally says something. If this made you think differently about that question, even for a second, subscribe and share it with 5 people who'd want to sit with it too. Tell me, honestly, in the comments, do you think we're closer to an answer than we've ever been? And what's the next question you want me to chase down for you?